Hi, welcome to Java Application Deployment, using the SaltStack demo. In this video, we are going to demonstrate the deployment of a Java application, using the SaltStack configuration management tool, on 3 different operating systems: CentOS Red Hat-based, Ubuntu Debian-based, and Windows. The complete process orchestrated through Jenkins's pipeline. The tools, which are used in this Java application deployment are: GitLab is used for source code management. Jenkins is used for continuous integration. SonarQube is used for code quality checks. JFrog Artifactory is used to manage the binaries. SaltStack is used for configuration management and continuous deployment. Terraform is used to provision the servers on OpenStack. OpenStack as the private cloud. Let's explore the workflow of Java application deployment, stage by stage. In the first stage, we will provision 3 virtual machines in OpenStack: CentOS, Ubuntu, and Windows using Terraform. A Jenkins job is written to pull the Terraform code from GitLab and execute it in OpenStack to provision 3 virtual machines. In the next stage, Jenkins job will pull the Java application source code from GitLab. A webhook is configured on GitLab so that the ongoing deployment job will trigger automatically when a commit happens on particular branch. In the next stage, the Java application source code will be built using Maven plugin, either in Jenkins's master or slave, based on a target operating system. In case any failure in the built step, pipeline will be aborted, the deployment package archived on Jenkins for future use. In this next stage, Jenkins uses SonarQube Scanner plugin for continuous inspection of code quality, to perform automatic reviews for static analysis of code, to detect bugs, code smells, and security vulnerabilities. SonarQube offers report duplicated code, coding standards, unit tests, code coverage, code complexity, comments, bugs, etc. when the code doesn't meet the quality standards, an alert mail trigger to the development team, and the pipeline will be aborted. Once the code meets the quality standards, the archived Java application package will be pushed to JFrog Artifactory repository. In the final stage, Jenkins will execute SaltStack state in all the minions, which will perform the below tasks to target servers: download and install Java, download, install, and configure Tomcat, pull the WAR file from JFrog, and deploy the WAR file in Tomcat. Finally, the Java application will deploy all 3 servers. Let's see the pipeline in action. First, we will create the 3 servers. We have the separate Jenkins job to create these servers. This job will create 3 servers in OpenStack. Let's trigger the job. The job has been completed now. Let us check the OpenStack. Here we can see all 3 servers are created: CentOS, Ubuntu, and Windows. This is a Java application web page of CentOS server. This is a Java application web page of Ubuntu server. And this is a Java application web page of Windows server. So, all 3 servers' web pages don't contain any content, because the code deployment has not been triggered yet. Now, let us see how the continuous integration and continuous deployment of the Java application happen via the Jenkins pipeline. Let's trigger the Jenkins pipeline for Java application deployment. In the first stage, the Jenkins pipeline job is preparing servers for SaltStack minion execution, adding all the servers as minions to the SaltStack server. In the next stage, the Jenkins pipeline job is pulling the source code from GitLab. In the next stage, it will build the Java source code using the Maven plugin, either in Jenkins's master or slave, based on the target operating system. In the next stage, SonarQube analysis is getting executed and validated against the quality gate. As the quality gate is passed, the Jenkins pipeline is pushing the build binary package to JFrog Artifactory. In the final stage of deployment, the Jenkins pipeline job will execute SaltStack code on all 3 servers. The SaltStack code is already pulled from Git and pushed to the SaltStack server. It installing Java, installing, and configuring Tomcat, pulling the WAR file in JFrog, and deploying the WAR package to the Tomcat server, in all SaltStack minions. Now the deployment has been completed. Let us refresh the web pages, to see whether the Java application is deployed and hosted on all the servers. For the CentOS server, here we can see the updated web page for the Java application. And for the Ubuntu server, this is the updated web page for the Java application. And finally, for the Windows server, this is the updated web page for the Java application. Let us see the continuous integration and continuous deployment in action. As a developer, let me make a visible change in a source code via GitLab UI and see how the changes are deployed automatically in the servers. Here, I am changing the heading in the application, which should be visible in the application after the automated deployment. Let's commit the changes. Let's see Jenkins. Here the pipeline job is triggered automatically via the webhook as the administrator using. The pipeline is getting completed. Let us refresh the web pages. For the CentOS server, here we can see the updated web page. For the Ubuntu server, this is the updated web page. And finally, for the Windows server, this is the updated web page. This is the complete workflow of Java application deployment using SaltStack on the various OS platform. For more information, please browse www.zippyops.com. Please follow us on social media, links are available in the description. Like, share, and comment on this video. Subscribe to our channel for the latest happenings on DevOps. Thank you for watching this video.